Hello, my name is Norfolk Daniel, and for my individual webinar project for MSc 440, I was asked to give options for a new fatigue tester. Before we go to fatigue testers, let me polish our understanding of fatigue and fatigue failure. Fatigue is a phenomenon that occurs in material during cyclic loading. Fatigue failure is a mode of failure as a consequence of cyclic loading and crack propagation during service. In Figure 1, you can see the cyclic stress profile that is typically applied in fatigue testing, and Figure 2 shows the cyclic stress profile during service. By doing fatigue testing, we can estimate the number of cycles for a material or part to fail, as shown by the SN curve. Fatigue analysis is done based on two main approaches for the part to not fail prematurely during service. One of the main approaches here is safe life. Safe life is focused on preventing the initiation of crack, typically in small parts that are easy to be observed and inspected. One subunit of safe life is the stress life approach, and this is useful for high cycle applications. For the testing, specimens are nominally loaded in tension and compression. They are loaded in the tension regime, which the stress is below the yield stress, and we plot the stress amplitude with respect to the cycle to failure to determine the fatigue limit and the fatigue strength. The second type of approach under the safe life approach is strain life approach. This is driven by the components that experience localized plasticity during the first loading cycle. This is useful for low cycle applications, especially part with notches and stress concentrators. It is designed for finite life and amount for plasticity. The second type of approach in fatigue analysis is the damage tolerance approach. Damage tolerance approach focuses more on crack propagation, unlike safe life approach. It assumes pre-existing crack damage within the material. Damage are inherent within the material from the manufacturing processes and is very hard to inspect material that has a large size. And with this damage, it is useful to manage the slow growth of cracks, as you can see from the Paris law. So the first option for a new fatigue tester is a servo-hydraulic load frames from Zwick Roller HV series. This servo-hydraulic load frame is a classic. It is standard and it is proven to be accurate. It is a classic fatigue testing machine for dynamic testing. It has industrial standard backed by ASTM, ISO, and ASE. It is accurate. It has a high load capacity of 50 to 2,500 kilonewton, and it also has vibration isolation leveling at the bottom of the tabletop. The servo hydraulic float frames has been used in this industry for many years. But here we have a new option, which is from Instron Electropulse. It is all electric. It has a wide variety of choices for the model, and it has proven to be accurate. In addition to fatigue testing and dynamic testing, it also includes statics testing, such as 3-point flexure test. It has low maintenance costs, as claimed by Instron to be almost 4 to 5 times lower than a servo hydraulic load frame. It requires no oil. It emits low noise. It takes in very low energy. It has a small footprint to save space, and the ease of assembly of the model lets anyone to assemble them in the lab without a hassle. It is more accurate now with a technology called DynaCell. DynaCell is a technology to reduce inertial errors due to fixtures and grips. It also includes self-aligning grips. It has a corrosion resistance T-slotted table. That means we can take any specimen for the testing without worrying about corrosion. And also it has up-to-date software for maximum control and customization. As studied by the Australian Department of Defence, Electropulse has a good prediction for the behavior of crack according to RightGraph. The blue dots follow the Paris law nicely and is aligned with the servo-hydraulic data. The limitation is that the reliable frequency might be lower than the specification. According to the graph at the bottom, in order to gain meaningful number of data points, the frequency can only be set up to 80 Hz as opposed to the manufacturer's 100 Hz. It has low load capacity, which is a max of 10 kilonewtons, as opposed to servo-hydraulic's lowest of 50 kilonewtons. The low load capacity makes the crack pre-opening slow. Next, the effect of vibration is noticeable and can create some noise within the data gathered due to the lack of vibration isolation. And this is a technical highlight from the brochure that was taken from Instron. There are a few models that we can choose from. The first one is E1000, E3000, and E10000. The number series behind the name refers to the dynamic linear force capacity in newtons. It also includes torque capacity and linear torsion for some of the models. So in conclusion, Zwick roll is a classic, but Instron packs more features for more convenient engineering without sacrificing accuracy. Thank you.